Welcome back to the first tutorial of Chapter 2 Sets 10th class SSC Maths. So, what are sets? We know that a set is a well defined collection of distinct objects, means the objects in it cannot be repeated, right? Distinct. Sets are written by enclosing all of the elements in between the curly braces. These are the curly braces. The elements that are present inside this set are separated by commas. These things are known as elements separated by commas and written in curly braces. So it is known as set. These are denoted by a single English alphabet. We cannot give a big name to a set. For example, it is a set of numbers. It contains 2, 3, 5, 7, 11. No. We can just give it the name as single alphabet. Suppose it is A, B, it is set A, it is set B, anything like that. Okay, let's see an example. P is a set of first 5 positive prime numbers. So the name of the set is P. What are the first 5 positive prime numbers? That is 2, 3, 5, 7, 11. We know what are prime numbers. That has only factor 1 in itself. 2, 3, 5, 7 and 11 are total 5 positive first prime numbers with a set name P. Two types of form in the sets. First is rooster form. So what is the rooster form? Let's take an example of a word school with the set as Q. So the name of the set is Q with the elements school. So what are the elements here? S, C, H, O, O, L. We have S, we have C, we have H, we have O and L. But we have 2 O's in the school but only 1 O in a set, because we cannot repeat the elements. A set has distinct element, as we said in the first sentence, distinct elements, so it cannot repeat. So that is what the rooster form says. When we write set in this form without repeating the elements, that is how a rooster form is. In rooster form, elements are not repeated. Therefore, a set contains distinct elements. Form is set builder form. How is this form? We will see. When we write a set by defining elements with common property, just as we said in the previous school. So what is the common property there? Number of alphabets in a school, right? While you writing it in the form of common property, we call it as set builder form. We will see an example to understand better. It has a following syntax that we need to follow. Let's take a rooster form as an example and convert it into a set builder form so that we can understand better. A set of multiples of 3 that are less than 20. So what are the multiples of 3? 3, 6, 9, 12, 15, 18, right? All of this considered as a 3 table, right? So it should write less than 20. The next number comes is 21, which will be greater. So we'll stop till 18. So what's the name of the set? A. This is the rooster form. Let's see the set builder form of this. A set builder form is in this type. We write the numbers here with the actual set, just mentioning the common property. So what's the property here? This is X. X means the elements of set. A set of all X, all elements means X, such that, this symbol is known as such that X, again X means these elements, is multiple of 3. That is what we wrote here, right? These are the multiples of 3. We are telling this element is X in a manner that this element X is multiples of 3 and it should be less than 20. That is what. So this form of writing of set is known as set builder form. Similarly, we can express rational numbers as set builder form with the name Q equals to elements of rational number is X, such that X is equals to P by Q. We know in the first chapter, first video, we have seen a rational number is in the form of P by Q, where P and Q are integers and Q is not equals to 0. That is what it is. Now let's see some examples of rooster form and set builder form. Okay. In a rooster form, we take a set with the name as V and we take vowels here. V for vowels, A, E, I, O, U, right, separated by commas. Now these elements are considered as X, such that X means these vowels is a vowel in English alphabet, right? There is nothing to specify, no less than, no greater than, nothing to compare, and nothing to specify further. So we can end it here that these are the English vowels of English alphabet. Now we have another set as A with the numbers -2, -1, 0, 1 and 2. So what are these elements? X. How? Such that these elements X is from where? From -2 to less than and equals to. X means the elements lies between -2 and 2. So these elements as X lies between -2 and 2 also equals to -2 and 2, that is less than and equals to -2 to 2, where these elements belongs to Z. Here Z means integers, because we have minus value we are taking as integers. Belongs to, this symbol is known as belongs to. We need to specify that where these numbers belongs, where the number of elements of a set belongs. So it belongs to integers, where this belongs to English alphabets. Next set is B. What is it? 1, 1 by 2, 1 by 3, 1 by 4, 1 by 5. Now X are the elements such that the value of X is 1 by n. Consider the value of n as 1, 2, 3 and so on. 1 by 1 is always 1, where n belongs to natural numbers. This sign is of natural numbers and it is less than or equals to 5. Because we ended here with the 5, so it's less than means all these numbers, equals to means this number 5. Next set is C with elements 2, 5, 10 and 17. So X are the elements such that X equals to n square plus 1. So this is the form we are getting as n square plus 1, where n belongs to natural numbers and it is less than or equals to 4. I'll just give you an example how it is done. Let's take this formula n square plus 1. Instead of n we will write 2, which is 2 square plus 1, which is equals to 4, plus 1 equals to 5. So first element is 2, next element is 5. Now let's take, after 2 is 3. Can we take 3? Yes, of course. 3 square is 9, plus 1 is 10. That is what we got. So for the 2 we will take as 1. So 1 square is 1 plus 1, which is equals to 2. We got 2, 5, 10. Now let's take last the element which is less than or equals to 4, means we'll take 4. 4 square is 16. 16 plus 1 equals to 17. That is where we are ending. So we are taking these elements of set in the form of n square plus 1, where n are the natural numbers, belongs to natural numbers. What are the natural numbers? 1, 2, 3, 4, so on. But we have restriction till 4, so it's less than or equals to 4. Moving on to the exercise, we have first question. Which of the following are sets? Justify your answer. So they are asking us to find whether the given question is a set or not. So let's take the collection of all the months of the year beginning with the letter J. So what is it asking? Number of months that start with the alphabet J. So what is it? First comes January, second comes June, the next is July. So we have 3 numbers that comes with the alphabet J. So yes, it is a set. It can form a set of these 3 numbers. So yes, it is a set. The next question is the collection of 10 most talented writers of India. Okay, we don't know how many there are writers in the India who are talented. So we cannot choose 10. Concept of talented writers in India is vague, as we don't know. Since there are no rules for deciding whether the particular writer is talented or not, and there is no particular number as well, so it is not a set. Third question, a team of 11 best cricket batsmen of the world. Now that was India, this is world, much greater, right? So we cannot just decide 11 cricketers from whole world, so it is also not a set. That is what the statement says. Fourth question, collection of all boys in your class. Okay, I know how many boys I have in my class, you know how many boys you have in your class, so it can form a set. If it is 20, 20, if it is 30, 30, whatever the number is, you can form a set with that number. Fifth question, collection of even integers. Okay, the collection of even integers, that is 2, 4, 6, 8. We know what are the even integers, right? Just as previous questions where we don't know who were the cricketers, we don't know who were the writers, right? But we know what are the integers, right? So it can also form a set. Now the next question is, if A is a set of 0, 2, 6, 8 and B is a set of 3, 5 and 7 and C is a set of P, Q and R, then fill the appropriate symbol with which who belongs to where and who doesn't belong. As the symbol is belong, when it is cut out, it means doesn't belong. So let's fill it the question. Does 0 belongs to A? Yes, it does. Let's fill it with the belong to symbol. Now, does 3 belongs to C? It belongs to B. So this is the wrong thing. It doesn't belong. Fourth one, does 4 belongs to B? Sorry, the third one, does 4 belongs to B? Is 4 in the B? No, 4 is in nowhere. So it doesn't belong. I think 4 is in A. I missed to write here. Now, does 8 belongs to A? Yes, it does. Does P belongs to C? Yes, it does. Does 7 belongs to B? It does. Right? Express the following statements using symbols. Okay, we need to express this statement using this belong to and no doesn't belong to symbol. The element X does not belongs to A. So how are we going to write? Which means the element X does not belongs to A. That is how we can write, right? Now the next question is, D is an element of set B. So D belongs to set B. Third one, 1 belongs to the set of natural numbers. Means 1 belongs to capital N. That is what the natural number is defined by. Fourth one, 8 does not belongs to the set of prime numbers. So 8 doesn't belong to the set of prime numbers which is denoted by capital P. Fourth question, state whether the following statements are true or false. Does 5 doesn't belong to the set of prime numbers? It's completely false, right? Because 5 is a prime number. Now the next, S is a set that is 5, 6 and 7 implies 8 belongs to S? No. So this is also false. Now minus 5 doesn't belong to W, where W is a set of whole numbers. Is this statement true or not? Yes, the statement is true because a whole number doesn't contain minus 5 which is an integer. Now the next question is, 8 by 11 belongs to Z, where Z is a set of integers? No, again this is false because integers doesn't have fraction numbers. It only have minus, that is negative, and positive numbers. Next question, write the following set in rooster form. Now we got this set in a set builder form. We need to convert those into the rooster form. So let's see how can we write. The first is, we have X element, which X is belongs to the natural numbers and smaller than 6. So that's quite easy. Let's write B, make a set. What are the natural numbers? 1, 2, 3, 4 and 5. Smaller than 6 means we should stop till 5. It is not smaller or equal to 6, so we cannot include 6 in this. Next, here such that X is 2-digit natural number So the sum of those natural number digits should equals to 8. So how are you going to write? Let's consider a random number, that is 17. It's a 2-digit number, right? So sum of these two numbers are 7 plus 1, which is equals to 8. So these type of numbers we need to write in a set. Set name is C. Numbers are 17, 26, 35, 44, 53, 62 and 71. So when we sum up all these numbers, it equals to 8. 7 plus 1 8, 6 plus 2 8, 3 plus 5 8, 4 plus 4 8, 5 plus 3 8, 6 plus 2 8, 7 plus 1 8. Now the next question is D. X are the elements such that X is prime number which is the divisor of 60. So we need to find those prime numbers that can divide 60. So let's write. D is the set name again. So 2, 3, 5. Can 2 divide 60? Yes. Can 3 divide 60? Yes. Can 5 divide 60? Yes. Are these prime numbers? Yes. Now we have 6. 6 divides 60? Yes. But is it a prime number? No, it's not. So we will end up till 5. Next question, E. X are the elements. X is an alphabet in a better. So E is a set name. We got B, we got E, we got T. We cannot repeat because those two forms is distinct elements. We already got T, we already got E. R is remaining, that is R. That's it. Sixth question, write the following sets in the set builder form. Now opposite of the previous question that we did. So let's see that we have a set with the name A and the elements. So let's look at the element. What are these elements look like? 3, 6, 9 and 12. It does look like the factors of 3, right? 3 table. So how are we going to write in a form of set builder form? A is a set name where X are the elements such that X is multiple of 3, right? These are the multiples of 3. Multiple of 3 and less than 13 because we end at 12, so it's less than 13. Let's take the set. X are the elements such that X equals to 2 power P, where the value of P lies between 0 to 6 and P belongs to natural number. So if we take the value of P as 0, 2 power 0 is 1, but we don't have 1 here, so we cannot take the value of 0 as it doesn't say equal to 0. It say only after the 0. It doesn't say equal, right? So we cannot take 0. Let's take the value 1. After 0 comes 1. 2 power 1 is 2. 2 power 2 is 4. 2 power 3 is 8. 2 power 4 is 16. And 2 power 5 is 32. And we cannot take 6 as well because it doesn't give equal to 6. It only said stop before 6. So it ends at 32. Now these are the factors of 5. 5 square, 5 cube, right? Similarly, we will write the answer as C is the set name with X elements such that X is equals to 5 power P, where the values of 5 starts from after 0 and ends before 5, where P belongs to natural numbers. So what are the values of P here? 1, 2, 3 and 4. 5 power 1 is 5, 5 power 2 is 25, 5 power 3 is 125 and 5 power 4 is 625. That's what we said. Now last one is D is equals to 1, 4, 9, 16, 25 and so on till 100. Similarly as the above question, it is like this: x elements, x equals to p square, where value of p lies from 1 to 10, where p belongs to natural numbers. Because we end up at 100, that is 100 square is, 10 square is 100. That is why we are ending at 10 and writing 11 less than 11, starting from 1 greater than 0. Now the 7th question is, write the following set in rooster form. Right? X such that x is natural number greater than 50 but smaller than 100. So it starts from 51 and ends at 99. Now integers x square equals to 4. So what are the values of integers? Means we have negative as well as positive. Plus 2 into plus 2, plus 2 square is 4. Minus 2 into minus 2, minus 2 square is also 4, as minus into minus is 4. X is a letter in the word loyal. We have L-O-Y. We already have L here, so we'll stop at A. We cannot repeat. 4th one is x equals to 2 n square plus 1, where the value of x is minus 3 to 3 and n belongs to integers. Because we have minus here, it belongs to integer. Okay, so take minus 3, then 2 into minus 3 whole square equals to 9. 2 into 9 plus 1 is 18, plus 1 equals to 19. No matter if we take 3 or minus 3, we get the same answer. 3 done. Let's take 2 or minus 2. N square is minus 2 or 2 whole square, that is 4 either way, whether you take minus or plus. 2 into 4 is 8, right? Plus 1 as it is, plus 1. 8 plus 1, 9. If we take 1 or minus 1, we get the same answer because we are squaring. So minus also becomes plus. So it doesn't matter what you take. 2 into 1 is 2 plus 1 equals to 3. If we take the value of x as 0, n square becomes 0. 2 into 0 becomes 0. Plus 1 as it is, plus 1. So what are the values? 1, 3, 9 and 18. E is a set which have values 1, 3, 9 and 18. Last question of this exercise is, we need to match the following from rooster form to set builder form. Let's see. So the first question is 1, 2, 3 and 6. It is a set with natural numbers and the divisors of 6, right? 1 can divide 6, 2 can divide 6, 3 can divide 6 and 6 can divide 6. So the first one is C, next 2 and 3. Prime numbers and the divisor of 6. 2 divides 6, yes. 3 divides 6, yes. Are those prime numbers? Yes. So it's A. Mathematics. We can see mathematics here. Nothing to solve. You can directly write D here. The remaining is answer B. Let's just check. 1, 3, 5, 7 and 9. Odd natural numbers and smaller than 10 means ends at 9. So this is B. That's the end of today's exercise of second chapter sets. Thank you.